So adding and subtracting fractions. Okay? Look at the first example here, please. When I'm adding fractions, this one's obviously adding because there's a plus sign. Okay? When we're adding fractions, tell me again what we do. As long as it's a common denominator, you just add straight across. Did I say it right? Just the numerator, right? As long as it's a common denominator, we add straight across the numerator and we keep the denominator that's already there, right? Right? Okay? So what steps did we just take? Add the numerators. So do you think that would be any different if we were talking about rational expressions rather than just fractions? No? Okay, so if this is our problem right here, do I already have a common denominator? Then what do? Add the numerator. What is 2 plus x? Oh, just 2 plus x? So what do you think is the most common wrong answer here? 2x. That's a very common wrong answer. What's another common wrong answer? Do you know? Yeah, they usually say 2x minus 8, right? They're trying to combine these denominators. Well, we don't do it here. Why would we do it over here? We wouldn't, right? Okay. Do I have a common denominator already right here? Yes, so just add straight across the numerators, right? 7x plus 4 over x squared minus 1. Questions? All pretty straightforward so far, right? And you're all thinking, yeah, you always give us the easy ones first. And I would say, I know. I want to give you the easy ones to give you confidence. Ready to do another easy one? How is number 2 different than number 1? It's subtraction, right? So in subtraction, if I have a common denominator, subtract the numerators. What is 8 minus 3? Oh, you guys are so smart. No wonder you're pre-AP. What are my steps? Is it any different when we are subtracting rational expressions? Do I already have a common denominator? Subtract then. How about x plus 2? A really common wrong answer is x plus 20. Why is that a common wrong answer? They miss the subtraction sign. So let me show you something that some people use that helps some people. I know it doesn't help everyone. Not everything I teach will help everyone though, does it? Okay? So 5 minus 2 is what? 3. What is 5 plus negative 2? Wait, so those two things are like they act the same way? Okay? So instead of this being a subtraction problem, what if I did this? If I made it an addition problem and changed all the signs, isn't that what I did here? I made it an addition problem and changed that sign. Whatever it was before, I made it the opposite. What do you think? Could that help you? If it does, use it. If it doesn't, don't. Okay? So what would this be then? I keep the denominator, right? And the numerator does what? Negative 8x plus 10? Because it's, if you don't do it this way, it's 3 minus a negative 7. Right? 3 minus a negative 7. That would still be 10, either way, correct? Any questions? Can I go back to this one real fast? Guess what a really common wrong answer is on that question once you get to the end? 1/3. Can you see where that wrong answer would come from? Because they tried to cancel out the x's and then simplify these two numbers. Why can't I do that? They're not common factors, right? It's just parts of a number. And like I told you yesterday, you can't just cancel parts of numbers, can you? Okay? You can only simplify factors. So how is 3 different? Not the same denominator, okay? Knowing what you already know, how would you do this problem? Multiply the second fraction by 2. 2 or 2 over 2? 2 over 2, right? Okay? Because the only thing you can actually multiply a number by and not change its value is a 1, right? So 2 over 2 is 1, and so we're safe with that, right? Because I know where we're going over here, can you go with me for just a second? What if I factored this number to be 4 times 2? Is that okay? I didn't change anything, did I? Okay? So I think if I have to get a common denominator, is there a factor they both share? What is that? A 4. Is there a factor that this one has that this one doesn't? What? A 2. Is there a factor that this one has that this one doesn't? No. Okay, they both have a 1, don't they? Okay? So this then would be my common denominator. Well, that's already the same, so what do I do with the numerator? Leave it, right? What's this missing? A 2. What do I do with that 2? I multiply by 2. Numerator and denominator. Because once again, I have to multiply by 1. That's the only thing I can multiply that doesn't change its value. So 2 over 2 is our value of 1 this time. So this becomes a 2. So then when I go simplify, I can just say that's 5 over 4 times 2, or 5 over 8. Right? I know that seems a little strange, but once again, I know where we're going. So just go with me for just a moment, please. Okay? So what steps did I take? Find a common denominator. And then we okay so far? So our first example problem, that's a rational expression. I'm going to draw myself a pattern so I have something to fill in. I like to fill in blanks. Okay? Also helps me sometimes not to forget stuff. Right? So what are the factors of this? 3 and x, right? What are the factors of this? X, right? We know everything has a 1. We're okay with that, right? So is there a factor they share? An x. Is there a factor that the first one has that the second one doesn't? A 3. Is there a factor that the second one has that the first one doesn't? No. So that is my common denominator. Now you know when I write my answer, what am I going to write right down here? 3x. Why do I do that? Because I'm a crazy algebra teacher and I like to have the numbers first and then the variables. Is it wrong if you wrote x times 3 right here? Absolutely not. Okay? So what is this denominator missing from here? Nothing. So what do I do with the numerator? Nothing. What's this denominator missing? A 3. What do I do with that 3? Multiply it. What does this denominator become? 3x plus 3. What's the most common wrong answer right there? 3x plus 1. Right? Because you forget to distribute. You remember to multiply the 3 by the x, but you forget to distribute. Please don't forget to distribute. Okay? Do I have a common denominator? Then what do I do with the numerators? What do I get? Am I done? Are you sure? So you think I'm done. What do people that don't think I'm done do? Eliminate the 3x's. Can I do that? But 3x is a factor. It's only multiplying in the denominator. But the top's not. I cannot simplify my 3x's here, can I? Good. We are finished. That is complete. Okay? What about this one? In order to know what the factors are, what do I have to do? Factor. How do I factor this first denominator? Yep, factor out of 2. Can I do anything with the second denominator? No. Look at the two denominators. Do they share any factors? X plus 2. Is there one that the first one has that the second one doesn't? Is there one that the second one has that the first one doesn't? No, so my common denominator is just 2 times x plus 2. So what is the first denominator missing from the common denominator? Nothing. So what do I do with the numerator? Nothing. Keep it the same, right? What's the second denominator missing? A 2, so I multiply numerator and denominator by 2. 18. Now that I have a common denominator, I subtract, right? X plus 1 minus 18. X minus 17. God bless you. Questions? All right, put your thumbs up in the air. This means I'm feeling really good right now with my thumb up. Sideways, I'm feeling okay-ish. Down, Okay? Good, good. Thank you very much. Okay, number 4. Those of you who had your thumb sideways, I was glad to see nobody's thumb down. Okay? Those of you who had your thumbs sideways, please be the ones asking questions in a moment if you need to. Fair enough? And if you don't know enough to ask a question, what do? Tell me that. Okay? So what about number 4? How am I going to do this addition of fractions? Find a common denominator. Okay? What's my common denominator? 35 is the smallest number that both of them divide into, isn't it? How did I get that? They didn't have any factors in common, did they? So I just multiplied them together. Guess what you do on rational expressions? Same thing, right? Okay? So 35 and 35. What is this one missing? What factor is this one missing? A 5. So 5 over 5, which is 1, is what I multiply by, and I get a 15. Which one's this one missing? 7, so I multiply this second fraction by 7 over 7, which is 1, and I get 14. Now that I have a common denominator, perfect, add straight across the numerator. 29 over 35. My steps? Find a common denominator, add your numerators. Okay so far? So, the first example that's a rational expression here, are there any common factors? So how am I going to find my common denominator? Multiply them together. What is 3 times x? Yeah, 3x, right? So what is the first one missing that's our common denominator? A 3. So I'm multiplying numerator and denominator by 3. Remember, I'm multiplying by a 1. Our 1 looks like 3 over 3 right now, which gives me 15. What's my second fraction missing? Excuse me, my second denominator, x. So I multiply it by x over x. Pre-AP question very quickly. What are we assuming about x? That x is not 0. What if x was 0? Could I multiply by 0 over 0? So I'm assuming that x is not 0, aren't I? Okay, good. And hopefully we would know that already because the fraction, the x is already in the denominator of the fraction. It can't be. Okay? I mean, only one person I know can divide by 0 and he's not in this class. Right? Yeah, Chuck Norris, right? Okay. He let me borrow his nunchucks for now. I'm protecting them. Just so Damien and Jade can know what I'm talking about. My nunchucks. Have I not shown you these before? See? So what should this be right here? 2x squared. Lest you think it's not cool, look at this side. It's also a pen. Yes, it is cool. Thank you for noticing. Now that I have a common denominator, what do I do with the numerators? Okay. In this case, yeah, we subtract straight across, don't we? I guess we should really change that to like combine the numerators. Whatever it tells us to do. Add or subtract. But you're smart enough to figure that out, yes? I mean, most of you. Just teasing. Last one, ready? Do these two denominators have any common factors? No, so how am I going to find a common denominator? Multiply them together. Can we talk about the denominators really quickly? Okay, here's where I'm going to write my answer, right? What did you just tell me to do to find my common denominator? Well, multiply them together. Did I actually do that? Those are multiplying together, aren't they? What did I not do? I didn't distribute. Remember we talked about yesterday, it's always a good idea to know how far is too far. We never want to go too far in algebra or life, right? Okay? So, is it okay to leave them just sitting beside each other? Do we have to distribute every time? No, it just depends on the situation. Okay? It doesn't say distribute right here, it just says to simplify, right? So, we're good. What is this denominator missing? It's missing in 2x minus 1, so I need to multiply by 2x minus 1, numerator and denominator. So that gets me what? 8x minus 8? No. What is it? 4. It definitely wasn't 1 though, was it? Okay. What's this one missing? X plus 3. So I need to multiply numerator and denominator by x plus 3. I don't know why I wrote minus. That's weird. So what does it become? 7x plus 21. Now that I have a common denominator, I combine the numerators, right? 8x plus 7x, 15x, negative 4 plus 21, plus 17. Done. Okay so far? Okay, show me again with your hands how you're feeling. Wow, some of you have 2 hands up. That's excellent. Some of you are too lazy to put 1 hand up. Excellent. Thank you. So I saw more hands up. That's good. I would be remiss in my duties if I did not go through 5, 6, and 7 with you. Because while most of you could do these by yourself now that we've done the first page, these are a little different. And I didn't want to just say, okay, mark it, set, go. Right? Now, your homework is going to be the back page, the 1 through 8, just so you know. Okay? But I really need to go through 5, 6, and 7 with you just to make sure. Okay? Because over here, what we did first was we found the common factors and used the factors to find the denominator, right? Same thing that we have to do here, but there's a little bit more factoring involved. Okay? Can I do anything to this denominator? Or do you already know the factors? You already know, right? It's x plus 2. That's the factor. Can I do anything with this denominator? It's the difference of squares, isn't it? How do I factor the difference of squares? X plus 2 and x minus 2, right? So I'm going to give myself a little pattern here. You can do this or not, I don't care. I'm just telling you that's what I do to help me figure stuff out. Okay? I'm going to give myself a little pattern and I'm going to think, do these two denominators share a common factor? What is it? The x plus 2 definitely has to be part of my common denominator, right? Does the first factor, or sorry, first fraction have another factor that the second one doesn't have? No. Does the second one have another factor that the first one doesn't have? Then that also has to be part of the common denominator. Okay? Why don't I write x plus 2 twice? Could I? Yes. If I do, I'm creating a lot more work for myself. You can absolutely get the right answer if you always just multiply the denominators by each other. Because that's what we did on that last example, right? We found the common denominator by multiplying these two by each other. You can do that. But we want to find the least common denominator, right? We want to find the smallest thing that they all divide into evenly. So that's why we only write the thing that they have in common one time, because they already have it. Okay? Is the first denominator missing something from the common denominator? What? X minus 2, x minus 2. Distribute, what do you get? 2x squared minus 4x. Yes? Yes, ma'am. Can I show you in just a second? Okay. That's a good question. She said, why do you distribute here when we weren't distributing on the bottom at all? That's a very good question, and I think you'll see why in just a second. Okay. Is the second denominator missing anything? So what do I do with its numerator? Just write it down again, right? Now when it's time to add the two fractions, if I hadn't distributed right here, what would I have to do? Distribute. Because I have to be able to combine my like terms to add my fractions. Does that make sense? Again, it was a good question. Okay? Now when I go to add my like terms, what do I end up with? 2x squared minus 3x minus 11. Can I do anything else to that? No? We're good? Okay. Any questions about number 5? What about number 6? What should I do first? Factor the denominators, right? Okay, how do I factor this first denominator? You can. Can you just go straight to the factors? X plus 3, x plus 4. Good. What about the second denominator? Can I factor that one? Ooh, I can, can't I? Both terms are divisible by a 2. Is there a factor that they share? Their factor they have in common. What is it? x plus 4. Is there a factor that the first one has that the second one doesn't? X plus 3. That has to be part of the common denominator. Is there a factor that the second one has that the first one doesn't? What is it? 2. That has to be part of the common denominator. Any other factors floating around there that we think we ought to throw in? No. We want to keep it as easy on ourselves as possible. What factor is the first fraction missing? If I multiply that by 2, I have to multiply that by 2, right? What do I end up with? 2x plus 12. Is there a factor that the second one is missing? What is it? X plus 3 there, x plus 3 there. What does that turn out to be? 5x plus 15. Okay. I'm going to do something to try to trick you. Did you see what I did? Did I trick you? I didn't? Why didn't it work? How do you know it's the same thing? It doesn't matter what order you multiply in, does it? Now, most of us want to keep it the same, right? We want to keep consistent so we don't forget something. Okay? So if I was writing this, if I was doing this on my own, I totally would have written x plus 4, x plus 3. So that it would be the same as these two back here. Okay? I just wanted to make sure we had that conversation. Okay? So what did you get for your numerator? I'm so glad. What do you think people who get it wrong put? Usually they put negative 3x plus 27. Why do they put that? Yeah, they forget there was a subtraction problem, right? Remember, instead of subtracting, we can add the opposite, and that might help if you're having trouble with that. Okay? Yes, sir. Yes, that's what I'm saying. We're adding the opposite. Yeah, absolutely. Absolutely. Okay, ready for number 7? Last one. Traditionally, the last one is hardest, right? Would you rather me not do it, or would you rather have seen it before we start homework? Yay, seen it. Can we talk real quick about this one real fast, though? Because you're going to see something like this on a homework. Do you see that there's actually one more step that we can do right here? Like that? What did I just do? I just factored the numerator, right? In this case, it doesn't matter. It doesn't do me any good. But what if one of our factors in our denominator was an x plus 1? Then I could simplify those, couldn't I? Okay? I'm just telling you, there is one like, I know at least one like that in your homework, or maybe 2. Yes. You could. Yes, that's something you could do to the top one too. You could factor the numerator as well. Okay? If it factors. I don't even know if that one factors or not. I don't think it does. Okay? Alright, number 7. You ready? What should I do first? Factor the denominators. Good. X plus 4, x plus 2. What's the other one? X minus 3, x plus 2. Okay? I'm going to give myself a pattern to fill out. Is there a factor that they share in common? An x plus 2, so that has to be part of our common denominator. Is there a factor that the first one has that the second one doesn't? X plus 4. Is there a factor that the second one has that the first one doesn't? X minus 3. Any other factors you think we need to put there? Good. X plus 2, x plus 4, x minus 3. What factor is the first fraction missing? X minus 3. So what do I do with that? I go ahead and multiply it out, don't I? aren't I using the distributive property? Yes. X squared plus 3x minus 3x, 0, and then minus 9. Is there a factor that the second fraction is missing? X plus 4, which leaves me 9x plus 36. Now that I have a common denominator, combine your numerators. X squared plus 9x plus 27. Just thinking off the top of your head, is that a factorable trinomial? I can't think of anything that would multiply by 27 and add to be 9. Not saying it can't be done, I'm saying I can't think of anything. Okay? So that's my answer. Any questions? Show me one more time how you're feeling with the thumbs. Okay, good. Thank you. I'm going to leave this like this up on the board. So if any of you want to go work on any of these before the bell rings, I don't know how much time we have left. A couple minutes. Other than that, 1 through 8 is due tomorrow when you get here. Any questions?